So hello everyone, hope you are really great. So today we'll be doing a question that is asked on Leetcode con today's Leetcode problem today, that is diameter of binary tree. So given the root of a binary tree, then return the length of the diameter of the tree. So diameter of a binary tree is the length of the longest path between two and between any two nodes in a tree. This path may or may not pass through the root. The length of the path between two nodes separated by the number of edges between them. Okay, so let's understand by taking this example. Copy. So what it is telling, diameter is uh, this. I'll just store it. You can for. So this is the diameter. Diameter is the length of longest path between any two nodes. So let's check what is the path between any two nodes. For example, if I take this and this, so path will be this one and this one. Okay, Hmm. the path will be this one and this one. So in this case, it is one and one. It is two. I will return to 0, 2. If I consider the path between 2 and 3, so the distance is 1 and 1. See here it is 2. Okay, here in this case if I consider 4 and 3, so the path is 1 1 2, so 1 2 3, so length is 3 something. For example, if I consider this also, take out from this also 4 to 3 also, from this to this, then it will consider this one, this one, this one, it is also 3. So in this example we can see the maximum we can get is 3. Okay, let's say let's see another example by taking our okay, sorry. So I take 1 2 3 4 5 6 7 8. Okay, 6 7. I'm just removing it. So in this case we can see, if I consider 8 and 7, this one and this one, so max will be here 1 1 2. If I consider something like 4 and 8, so we'll get 1 2, 3, 4, 5. So here we will get 5 if I consider this. If I consider 4 and 7 also, it will be same. I will say 1, 2, then 3, then 4, then 5. If I consider something here, 1, 2, 4, this one, wait. Hmm. So if I consider 4 and 1 here, it will be 1, 1, 1. So I can say the maximum diameter. I can say that if it is this is the maximum diameter, I can say. Okay, in this case. So likewise, what we need to do is we need to what we can do it, we can find diameter or diameter a diameter by checking every two nodes. So what I can do, I can do that if I am in mm, I am in one. I've guessed one. I'm in one. I'm seeing if I'm in one. What I can do that I will check the height of left. That is, it is height of left is 3, and height of right. Here it is connected to null. Uh, sorry, null. So it is 0. So if I want I choose 1, then I may get 3 as the maximum distance between left and right. So if I take 2, this one, if I want to find the maximum height, what I can do, check get the maximum height in the left side, that is here it is 2, and maximum height on the right side, that is here it is 1, 2, 3. So here it is 1, 2, 3, that is so for 2 we get maximum left plus maximum right, that is 2 plus 3. So what I'm telling that we can find. So what I'm saying, we can find for every node maximum left, uh, for every node maximum left and maximum right, and we will just add it here, left plus right. We'll do it for every node, for this node also, maximum left plus maximum right. For this node also, maximum left plus maximum right. Here in this case left will be 0 because it is connected to null. Okay, here also we can do that, do this, null, null, 0, 0, 0, 0. Hmm. So we'll find for every node maximum left and maximum right and add it, and check whether it is which one is greater. Okay, in this example what can do, let me show it. uh, So if I consider 1 here, 1, so maximum left will be 2. I can see it completely. Maximum left height will be 2. This for this is 1, this is 1, so it will take 2, and for this it will take also 1 and 1, so maximum right is 2. So for this maximum left plus right will be 2 plus 2, that is 4. And for 5 we can see it is that it is 0 and it is 1, so we'll just say 1. And for 1 2 will, if we check, we can say this is 1 and this is 1, we'll just say 2. So for 3 we will say that is null, this is null, this is null. So we can say this here is 0 0, so we'll just say 0. For 3 if we check, maximum left plus vector right will be 0. For 4 if we check, maximum left plus maximum right will be 0. So we can say for 2 if we take consider maximum left plus maximum right will be 2. For 1 if we consider maximum left plus maximum right will be 4, because maximum left is 2 and maximum right is 2. So likewise we'll consider every node and check which node is which node is maximum, and just return it. Okay, so let's go to the code what I have done. Okay, so this is the code. So what I have done is uh, this. So what I've done is I am storing the max value in this max array of 1. Okay, so I am supplying the root and max value in this function max height, and after solving it I will just return max zero. So I will just say, I will just you can do it, uh, uh, how it will store the max value in max zero. So in this max height, uh, we'll check left height, max height, get the left max height, and get the right max height. Okay, after getting left max height and right max height, we'll check we'll check whether the left plus right max height is greater than max 0 or not. If it is for initial case, it will be greater because max 0 is considered to be 0. Okay, here it is considered to be initially max 0 will be 0, to be 0. So after storing it, then we will just return the maximum of max left or right. Okay, so again it will check for every node. Okay, likewise it will check for every node and return the maximum here. Okay, so for in this example what it will do, mm, so let's see if I am in 1 here. So what I'm doing, I'm checking left max height. So root left comma right max, root left for max height of root left. Okay, so what it will give, it will give it is 1. Okay, and and I will check right max of 1 plus right max, it will max height of root dot height. Okay, so it will give here 1, so for this it will be 2. Likewise if our root will be 5. Okay, 5. uh, so 5 for root, our root will be 5, so we'll check left will be null. So you see root dot left, if root is null then it will return 0. So the left part it is 0 and right is it will, you can see easily it is 1. So it will find recursively and it will give you 1. So 0 plus 1 it is 1. And after this we'll just provide the maximum height between this to the parent. For this the maximum height is 1, so I'll just provide it to parent here 1. Okay. Hmm. And for this the maximum height will be 1. I will just provide it to the parent. Okay. So here it is, the maximum height here is 1 plus 1 it is 2, it is 1 plus 1 it is 3. So 2 plus 3, if I'm in root node, it is root, it is 1. It will check the maximum left height, simply 1 plus max height of root left. So we have stored the value of root left, that is 2. We'll just return the maximum left height root 2, and maximum right height I will store it here, root right comma max, that is 3. It is 3. So here it will return 2 plus 3 and check whether it is greater than or current or not. It will, if it is greater it will store here max 0, and I will just return method maximum left and right. It is quite complicated, but if you look closely you can understand. Then I will just return max will be stored here. I will just return max of 0. Okay, so thank you. If you have any concern or doubts you can ask. So that's it for today. If you like my content, like, and subscribe. Thank you.